Hey, good morning, everyone. Today I want to talk about my understanding of Scala. And when I start learning this language, I'm not looking for a new job for Scala. Yeah, I just want to resolve some pain or some trouble I always met in Java world. I couldn't find a good solution. That's why I turned to Scala to find a better way to handle our problem. So now let's start from a very simple example. Like this maybe is some work we do every day, like get data by, for example, we want to create create a method, right? This is obviously very normal. So ID with string data can be anything, but let's make it simple. Okay, for now I just make a string. Now let's think about this. It receives ID and give you back the data. So the code here could be like if ID equals A, let's make it simple. It's just a example, right? A is a data. Otherwise, okay, not found. Oh, sorry. Yeah, I have some mistake here. Okay. This is a very, very simple code. Let's try to run it. Yeah, very, very simple. So now as a Java developer, first question, is this ID null? So in Java, we will say, okay, first step is defensive code, right? Okay, so now let's say if null, then what? Then what? Okay, here is the first question. What we should put here? A log, or through new exception, or return null? Okay. Every decision you made will impact your user because you don't know who are going to use this method, right? When we start learning Java, when we start learning design patterns, we always emphasize reusability. But your code in the first line is not reusable because if you throw exception and your user doesn't know they need to catch exception, you will crash their code. If you say log, but your user do want to receive some feedback, not log, nobody will check log, okay, then it's another problem. So there's no very good way say I can fit all users requirement. Okay, so what Scala did is, let's forget about it. We don't do this. We don't do this. Okay. Let's leave it for a while, and later I will explain what we do. Second problem is the return value. Okay. If anything wrong here, we want to return a error. The same question comes back again. What is the error? So, exception, log, or null value? We don't know. So in Java, in Scala, at the very beginning, you will learn something called option. Option means it could be null, but it's not null, right? It can be empty, but it's not null. So by do this, we do this simply, we do this. This one will be null. So if we try to find a B, you will get a message say null. Okay, good. not good enough. Why? Because you lose the error message. You don't know what happened. You just say, okay, this function didn't return me anything. But why? I don't know. Another question is, will your user accept option? What about they want to know what happened, right? So people will say, okay, I will return either. So let my user know what happened. So for either, you will say right and left, not front. Now let's do this way. Okay, this time good. You say not fun. But later when you read the book, you will find either is also not a good choice. Because either if you have multiple error messages, you can hardly combine them. So now it leaves we very embarrassing environment. Like we never know what our user want to receive. We don't know. We don't talk to them, right? Because your code will be released to the whole team, maybe whole company, maybe over the world, right? If it's open source. So really, we don't know what is this. We have no idea what is this. Let's say F. Let's put it as F. So this is a new thing that Java developer never knows. What is F? F can be anything. Because I don't know what user can provide, so I have to assume that can be anything. And let's put it as this. F. So by this way, F can be anything. What is our arrow? I also don't know. So for now, let's forget it. The only thing I know is what I should return. How to handle arrow? I have no idea. What is your F? I have no idea. Then it has a problem. How do I return value? How do I raise arrow? But think about that. The only thing you want to consider is two, right? How to raise an arrow, how to return a value. That's it. So now let's say, I don't know what is your F is, but I know your F must provide some function that I can use. I will force you to give me a function called a monad arrow. And here, for any F, I want an arrow. Possible arrow comes back. What is the arrow type? In our case, it's string. We can put string here is because here I only want to return a string. I don't want a through exception. For example, if you do want through exception, then you change this one as exception. But for now, in this case, this arrow type decided by me. Okay, and the user can convert string to whatever they want. Like if they want a through exception, you just convert this string as new exception, but not inside our code now, because this is decided by me. Another thing can decide by me is this string. Right? My return value type is decided by me. Okay, now we have a monad arrow, so we can use it. We can say F monad arrow. So monad arrow has two input parameters, F and E. Now we need to decide what is our E. Our arrow type is string. That's what we wrote here, right? So it's string. Now you can use this F to raise arrow. Okay, and oh sorry, this is not raise arrow. Here is raise arrow. So we can say this F raise arrow, and here we can say pure. Yeah. Now where this function from is monad arrow is from a monad plus applicative arrow. So this one actually is a function of applicative arrow, and this is a function of monad. Now maybe you are very confused about what I'm talking about. So I can make it easy. Monad arrow, you can treat it as an interface. Okay, this interface assure you have two methods can be used. Not only two, but here we use two methods. One is pure. Pure is if you have any string, you can make this string as an element of this container. This F is a container. And if you have any arrow, you can also raise arrow. But how to do it? How do you raise arrow, and how do you put the data into the container? We don't know. Actually, this is just an interface. It can do nothing. Actually, it can do nothing. It just tells user, okay, we have to find these functions from your container. Okay, but I don't know how to do it. You should tell me. Now, suppose you have a team, okay, and you wanted to use this get data by ID. So the first thing you want to do is you need to let the user know, sorry, the computer knows how your container can be converted to monad arrow. Now let's assume your team is a new team and the people are not very familiar with Scala, and the only thing they learned is option. So now let's see how do we convert option. So we say implicit object option, right, as monad arrow. So I say option can be a kind of monad arrow. Yeah. And for any type, we have, sorry, extends monad arrow option, and here is your arrow type. Your arrow type can be decided by you. Here makes things easier, simple. We just put string here because our arrow type, you know, is string. So I don't want to make it too complex. Make it simple. Okay. So this one defines, okay, I have something can implement this monad arrow with this option as our share. And now we implement all necessary functions. So these functions are required by monad and applicative. They are empty because, as I said, we don't know. The machine only defined the interface, but they don't know how to realize it. Now we have to realize it. So first thing is flat map, which is quite easy because option has flat map. Right? I don't need to worry about it. Just do it. And tail recursive is a little bit complex because let's say FA. When we run it, we have option either. So we could got some result like sum left s. Our arrow type is string, so I put s here, and what we want to return is an option. So left means something wrong, right? Left is a type of either. So either left is means something wrong. If something wrong, we just say return none. If all of things are right, we will return sum A, and case if we got none, then obviously we will return none. So that's it. We resolved it. How do we raise error? For option, it's none, right? Because we don't want to see any error message. We just put none here. Handle error with means if your previous calculation returns none, then how do we handle it? So we will say FA match case none, which is almost everything. So they want to transfer something to another option, but here really not necessary because we know it's error, and there's no string comes in. This string will never match, but we don't have string to provide, right? Otherwise, if you have some data, okay, then FA, oh sorry, my mistake. Actually, you will never meet some data because option, when you do handle error with, it's impossible case. So let's say now. Yeah, let's say now. For option, you have no much things can do, but always returns now. For pure option is easy. We say, okay. So we provided the implementation. We already tell our computer how to convert an option to monad error. Now let's try to use it. And this is our implementation. To use it, I will say import share converts dot option monad error. Now let's see if we put B here. Yeah, it gives one. Now, if we put A here, okay, very clear. Now, option, you can see we omit lots of error message, and most of the time it's not satisfied with our user. So, next thing we need to do is implement our either as monad arrow. Monad arrow. So either string. Same as before. Same as before. But now you see there's a problem. There is an error. And it says type construction is mismatch. Why? Is because our definition of this container f can be anything, but it has only one element, one type inside it. But your either has two. Okay, that means you cannot use either. How can we resolve it? We can kind of cheat our container, say, okay, we have a title of S, right? And this one takes only one type, but this one is, I put string as our arrow and A as our data type. So by this way, we eliminate one requirement of input and put it here. This one works. Now, let's implement it. Same thing. So you will have a feeling. We are doing get, we were doing get data by ID. But now what we are focused is totally nothing related to that method. We focus on our own task. Our task is create a either type monad arrow. That's it. We only think about the story in either and monad arrows. So first thing is flat map. Fortunately, either is also a monad, so we have flat map. And this guy a little bit confused, so let's do it later. Raise arrow. Suppose you have arrow message. How do you make it as either S? Very simple. Just do this, right? That's what we did for either. Header arrow width, if your previous one is either. So if this guy is something wrong, what you will do? What is your E is you will pass this E to this function to get a new either. That's how that's what handle arrow width means. So it means you have an arrow but you want to convert it to another arrow. That's what it means. If you have right stuff, then you don't do anything because it's not arrow. Okay, so that's it. Because you have only two choice, you don't have other things. Pure is right. Pure means you have a correct type of data and you just want to put into this container, so use right. Now last thing we left is this guy. So suppose we have a right, we call it FA, then we got a either of either. So that's what it called tail recursive. So if we have it like this, left of left E okay, so sorry, this is impossible. So if the first either is failed and the second is A, so you will, oh sorry, left E is impossible because your first left can only have string, right, as an error message. So if this is the case, you just return it back. Otherwise, if you are right and you have right B, you will say right B. Otherwise, if you have right but you have left A, then in this case you got some trouble. Is okay, this definitely is arrow, so it's left, but A is type A. Only thing we can accept is string, so I have to do this. So here is a weakness. It indicates our original design of this arrow type as string could have some potential issue. Later, if we want to improve it, this string can be should be changed to anything. So let's make it later because this is not a big issue in current solution. It could be improved later. Okay, so now we finished the either. Okay, if you want to use either, you just do this. Either as monad. Now you can see I didn't change any code. Okay, A is still right. B, you can see you got left not found, which is what we want. So that's the idea of reusability. So we don't force user accept what kind F they have to use. Most of the time, why people don't use our code? Why people repeat implement functions again and again? Yes, because they can't, right? Your environment is totally different with them, and they can't. But in our world, we can easily resolve this problem. And if we have something if we have something more, like we have this one and this one, we have something like this. Okay, this means we do first get data by ID, then we retrieve this result is a string, right? And let's do this, get data by ID again. So these two, let's make it more complex so we can see what happened. So for example, in the second call, we print out something. Let's print out something. Got result as result. Okay, that's right. Yeah. So first step got A as a result data, right? A is as the data. This is what we got. And we use this string as an input of the second query, and we got not found, which is right. Yeah. But if we have something wrong in the first step, yeah, you will see the second step will never be called. That is the reason at the beginning we say we don't define this ID equals null. Because if ID is not existing, it will never call your function. So that's how our functional programming guarantee our code is safe. We use this F, and F is a monad. This flat map is monad. So this safety comes from this flat map. The flat map guarantees if the first call failed, it will never call the second and the rest of the functions. So flat map provided by monad. And this F, you can give me any F, but it has to be a monad. Because I need a monad to guarantee my function call list. A list of function call is safe. And the only weakness is here. If you put a null here, of course it will crash. So, as a developer, normally we do things like this. We validate our data first, then start to pure function call. And pure, and pure, and pure. So anything wrong, we will cut it from here. The rest of things is safe. Which means if you give me a right data type here, you will never ever be able to crash in the list. You can only receive error message, but no crash. Okay, so here's our design pattern. Firstly, we don't throw exceptions from our code. We only raise error, so no exception. And secondly, we need a F to provide monad. Here I need a monad L, which is richer, right? But essentially it's a monad. So with monad, we can use flat map to combine our function calls and make sure the whole process is safe. By this way, we save tons of defensive code. we removed the worry about log or error or exception or return null. All of these things is dangerous and makes user lots of time we will say null exception from Java code. Why? Is because people returns null, right? We never return null. And we can simply switch our solution, just to provide a small function, and the whole business code will be okay. Yeah, you can just a word you can switch your functions. So if I switch back to option, and let's see what we got if we switch back. Now, see, very safe, very smooth. You don't need to change any code. You just need to provide a small definition of your interface. Yeah, so I will encourage people to adapt this solution. And moreover, what is F? We say F is a monad arrow because here I need monad arrow. But F actually can be anything. It can be huge. It can provide database access. It can provide multi-threading, right? Fiber. It can provide even streaming or whatever other things you need, like read file, read HTTP, write HTTP. It can provide anything. All you need is just that the computer knows how to convert your F to provide these functions in other modules. And these modules are reusable. Not only in this place, it can be used anywhere. So one-time coding used forever. So the whole functional programming world is reusable. Every piece of code is reusable. Like this code definitely is reusable. And this code reusable, right? Finally, you just combine your functions one by one, and that's it. So I used to describe how different coding style between Java and FP, or let's say O. I don't know if it's correct, but I have such a feeling. So as a Java developer, we always try to make a huge function, powerful, huge, and big. Yeah, let's see. So I hope say, okay, you give me a data to my black box, and I give you result. That's what Java developer thinking. But FP is not. I say FP like what? It's like a wall. A wall is built with bricks. So you go to one brick, and lots of bricks, and finally still brick, and then you got the result. So those bricks, you can treat it as a black box, like here. But the good part is, firstly, it's very clear to show you step by step what I did. Secondly, very easy for you to replace one brick to brick 2, right? So you don't hide your business steps. You just display them in a long list, but people can clearly see what you did, and they can easily replace one of them. Yeah. This solution, I don't like it. I used to have a bad experience. Yes, I saw one of my colleagues he implemented something like this. But this is a huge code. Inside it, it says filter, which makes his code actually is get active data by. But he didn't reveal it in the name. He put it as a black box. He hoped people will read all the code before using it. But we don't have it. We don't have time. Right? Most of the time we don't have time. So we are misleading. And we use it, and finally in production people say, hey, you lose all inactive data. What? So that's what happened. In FP, we don't write huge method. We don't write huge class even. So look at my code here. Every method is just 1 or 4 lines. Maximum is 4 lines, right? Most of them are just 1 line. That's what we did. That's what we did. And we don't expect people read it before using it. You want to use it? You just import it. That's it. Don't read it. But it works. Why it works? Because it's based on type. So every method you have to guarantee, if I give you a right type, your method works fine. You just need to guarantee this thing, no other things. So lots of benefits. And other things is unit test. People trust unit test. I don't trust. Unit test is a cost. Think about that. If you have if then, how many unit tests you should write? At least 2, right? Then in your code you get another if then you need 4 tests to go through all the paths. What about another one? 3 if then. That's normal in Java, right? That's very normal. Then it's 6 unit tests. What about one more? It's 12 unit tests. And if you unfortunately changed something here, you need to change how many unit tests. This is a huge cost. So what we do in functional programming, we only put 1 single if then in our code and resolve it. The next, and if anything wrong here, you don't change all of this because they are independent tests. You don't touch this. Your code only do unit test here. It saves huge time, huge costs, and very reliable because we provide reliable through this guy. Not by unit test. Unit test you have to go through all the paths. Make sure it works. So that's why I worked 20 years in coding. Every time when I hear people say I'm a test-driven developer, I always laughing. Are you really doing that? To me, it's mission impossible. It's not doable. Don't cheat me, right? But now we can. Why? Because we're using a new pattern to handle our code. We can guarantee if this code can guarantee yourself is safe, you don't have to worry about other people. And when other methods get changed, you don't have to worry about it. That's how we do. So it resolved my problem in real time, in real world. So I hope you can understand our philosophy. How do we design our code? Why we have F here? What is this guy? Right? all of these things, I want you start to understand it, start to using it. And that takes a little bit of time to learn, I know, but it gives you huge benefit to save your problem, to save your world. Thank you.